The weight of your body is approximately 79% water. But if you live in Boise, you live in a desert. How is it that your body is able to retain all that water and not just shrivel up and die? The answer lies in diffusion, osmosis, and cell membranes, the topic of this week's lab. Now, before we can talk about the movement and retention of fluids in the body, we have to have some terms. We have to have some vocab that drives our discussion. The first word we'll talk about is a solution. A solution is simply the mixture of two or more substances, and these substances can be solids, liquids, or gases. We tend to think of a solution as a solid dissolved into a liquid, like a spoonful of sugar dissolved into a glass of water, but you can have liquids dissolved into liquids, gases dissolved into solids, and any combination of those three things. When you have a solution, the solute is the thing that is getting dissolved. Usually it's lower in volume, such as a spoonful of sugar compared to a glass of water, but it's the thing that you put in and dissolve. And on the other side, the solvent is the thing that is doing the dissolving. It is the water that dissolves the sugar. The water is the solvent. I call water the universal solvent because we use it to dissolve just about everything. The grease on our dishes, the dirt on our dog, it all gets dissolved by water. What is homeostasis? Homeostasis, basically, is what keeps you alive. Homeostasis is the body's balance. It is the body seeking equilibrium with its external environment. Osmoregulation is a specific process within homeostasis. It's the process by which cells and organisms maintain their fluid and electrolyte balances with their surroundings. And last but not least, concentration gradient. Concentration gradient is a difference in the concentration of a dissolved substance in a solution between some area of that solution where you have a high density of that solvent and some other part of that solution where you have a lower density. And particles or molecules are going to be moving from an area of high concentration to an area of low concentration. Think of a bunch of people trying to run out of a building. You have a lot of people inside the building and they're flowing out, okay? Just like molecules. What is the force, or how do molecules move along a concentration gradient? What is the force that propels their movement? The answer is in Brownian motion. Now, some of you who are falling asleep right at this moment think that Brownian motion is probably the thing that happens to you after you've had a large breakfast in the morning. While that is partially true, we're going to use a more scientific definition of Brownian motion. It is the movement of particles due to collisions with the molecules around them. Think of it this way. Molecules are always in motion, right? If you pump up a tire, or an inner tube, or a raft, and you leave it out in the sun, it gets hot, right? It expands. That's because the molecules of air are moving around. Okay, if you have molecules of air moving around, they can collide with particles of dust, and it's the molecules of the air that will move the dust around. The same thing happens with diffusion and osmosis. Let's look at it this way. Here is an example of diffusion. Let me get my cursor up where you can see it. Here we go. Look at this box on the top left. We have a box filled with water. It has a membrane down the middle, and you have a high concentration of molecules on the left side of the membrane. As the water molecules bounce around, they hit these particles of the solute, and they bounce them across that membrane. And they keep bouncing them across the membrane until you have an equal concentration of molecules of this solute on either side of the membrane. That is diffusion. Brownian motion is the collision of the water molecules bouncing against the solute and driving them from an area of high concentration of solute to an area of low concentration of solute until we have an equilibrium established. How does that relate to water and osmosis? Osmosis, like we are saying, is a specialized type of diffusion. Osmosis is the movement of water. If someone asks you the difference between diffusion and osmosis on a quiz or a lecture final, wink wink, osmosis is a type of diffusion, but it refers to the movement of water from an area of high concentration of water to an area of low concentration. Let's get the cursor up here again. There we go. We have a beaker full of water. We have a membrane going down through that beaker. And on the left side of the membrane, we have a high concentration of sugar. On the right side, we have a low concentration of sugar. That's important. If we have less sugar here, fewer sugar molecules, well, in that same amount of space, we must have more water molecules. And as these red arrows handily show us, the water is going to move where we have a higher concentration of water, this direction to the left, to where we have a lower concentration of water. But that is misleading, and students trip over this a lot. There's nothing to keep the water from moving in both directions. Excuse me, here's my cursor. The water can move from left to right, and it can move from right to left. There's nothing to keep it from flowing both directions. It's just that most of the water is going from the high concentration of water to the low concentration of water. That is osmosis. Now there are three terms that help us understand concentration gradient and the direction that water is going to flow. And these terms usually result in a lot of confusion. So let's look at them for a second. The first term we're going to look at is ice-osmotic. And the first point I want to make is that these three terms usually refer to the concentration of solute outside the cell. Everyone heard that. Ice-osmotic usually refers to the concentration of substances outside the cell. Let's try and remember that for a second. Here we have a cell, right here, and on the outside of the cell we have a solution. And we're saying that these two solutions are equal in their concentration of solutes, and they are said to be ice-osmotic. And the flow of water is going to be equal inward and outward from the cell. If we look at these red blood cells on the right here, okay, they're neither shrinking nor expanding. They're said to be flaccid, okay, because the movement of water is equal in and out of the cell. Okay, here's where it gets tricky. Let's look at hypoosmotic. The total number of solutes in a solution is less than that of another solution. There it is. If we refer to the cell, get my cursor up here where I can get my cursor. Okay. The solution outside of the cell is said to be hypoosmotic in relation to the solution inside the cell. There are fewer solutes outside, and that means if there are fewer solutes outside, there is more water outside, and the water flows into the cell. Okay, and the cell is said to experience turgor pressure. It swells because the water is flowing inside the cell, and these red blood cells can actually burst from this condition. Hypoosmotic is sort of like the word hypoglycemic. It means less than. Hypoglycemic is not enough blood sugar. Hypoosmotic is a lower concentration of solutes. Hyperosmotic is the opposite of hypoosmotic. It's hyperactive. It's extra. The solution outside the cell is said to be hyperosmotic. There are more solutes outside the cell. If there are more solutes outside the cell, there is less water outside the cell. That means, relatively speaking, there is more water inside the cell, and the water is going to flow from inside the cell and go out. Plasmolysis occurs because the cell membrane retracts from the cell wall and things start to cave in. The red blood cells here are shrinking. That is what happens when you have hyperosmotic. Now, if those three terms are still confusing, replay the video. Make sure you got them right. It's important for the week's lab to know those terms. What the heck happens with the semi-permeable membrane? The membrane allows the passage of certain types of molecules or ions, but not others. It controls the flow of water and ions, and permeability can depend on the size of the particle. It can be related to the pH and the ions that are the ionization of your molecules. Are they positively charged or negatively charged? Remember this. It will happen again in lab this week. And the rate of diffusion can depend on temperature, the overall concentration of the solute. If you have more solute, you're going to have a more rapid concentration. Okay? And other things such as mass of the molecules, density of the medium. Does water flow more quickly through air or jello? Chemical structure and polarity. Thanks for coming. That's the end of our presentation.